Hi, this is Chris Lindberg again. I'm here to talk about Example 3 from Unit 64 in the 6th edition of Mathematics for Machine Technology by Robert D. Smith. I'm an instructor at Shoreline Community College. First, we want to analyze this problem. We want to find out what information we need in order to find out x. One way I can see that we might be able to find out x is by drawing a vertical line from the center of the circle to the base of the v. If we can calculate that and we have the radius and add that to the top of that, we can have the distance from the base of the groove to the top of the circle. Then if we can also calculate the distance from the groove to the top of the groove, perhaps with this triangle constructed, then the difference between the two lengths will be x. So let's see if we can do it. First, we'll calculate some of the different figures we'll need. We need half the distance across the v. Well, the v can be calculated, that distance across the v can be calculated from the 2,750 thousandths at the base minus the 250 thousandths on the two sides at the top, and dividing by 2 we'll get 0.1. So 2 times 250 thousandths is 500 thousandths, taken from 2 and 750 thousandths is 2 and 250 thousandths, divided by 2 is 1 and 125 thousandths. Another thing we're going to need is the radius. The radius can be determined from the diameter. By dividing this diameter in 2, we'll get the radius. So dividing 1 and 250 thousandths by 2, we get 625 thousandths, the radius of the circle. The other piece of information we're going to need to make the calculations is the angle 2, which, because it's drawn to the center of the circle from two lines that are tangent to the circle, splits the angle in half. That angle, 65 degrees 40 minutes. So if we divide that by 2, we get 32 degrees 50 minutes. Now with this information, I think we can solve the problem. First we'll calculate the h2 here, the hypotenuse, the distance from the base of this groove to the center of the circle. Since we have the opposite and we want the hypotenuse, we'll use the sine function. Rearranging the sine function to solve for the hypotenuse, we get this, and then substituting the values, we have this. Substituting in the value for the sine of 3250, and our answer then is 1.152717256. That gives us h2. Now let's calculate a1. Since we have o1, all we have to do is calculate the adjacent. Since we have the opposite and we need the adjacent, we're going to use the tangent function. Let's rearrange the tangent to solve for the adjacent by multiplying both sides by the adjacent and dividing by the tangent. That gives us this formula. Substitute in the values. We have this, do the division, and we find out that the adjacent is 1.743429928. Now I think we have all the information we need to solve the problem. So let's calculate x. So x will be h2 plus o2, the radius, and then we subtract a1. Now when we plug in our numbers, subtract o2 from h2, subtract a1 from that, and our result is 0.03428 0.7328. Now, since we want to round this to 3 digits, and the 4th digit is 2, we simply drop the remainder of the fraction of our decimal places. So we'll drop 2.87328. And our final result is 34 thousandths of an inch. I hope you enjoyed this. Watch it again or watch one of our other programs. Bye.